From here on planet Earth, one of the brightest stars visible to us is a star known as Sirius. And I'm sure if you've ever looked into the night skies, you've probably seen this star. It's extremely easy to see. But you might also be aware that Sirius is not just one star. It's actually two stars, one large one and one small one on the right. Here's what an actual image of this looks like, and you can see Sirius B as a tiny little spot in the bottom left. And that's because Sirius B is what's known as a white dwarf. It's a type of a star that our sun will also become in the future. There is, however, a small mystery about the star. And the mystery here is in regards to the total mass of Sirius B. It's roughly around double the mass of a typical white dwarf we've discovered in the galaxy, which sort of makes them look like this if we were to create them in a simulation. A typical white dwarf is usually around half the mass of our sun, and that's actually what our sun is going to become in a few billion years as well. So this is what we usually find, and this is what we've discovered everywhere in the galaxy. Sirius B, on the other hand, as you can see, is smaller in size because it's more massive, it's more dense, and this is actually what happens to white dwarfs. The more mass they get, the smaller in size they get. Now in this case, Sirius B is just a little bit more massive than the Sun, meaning that it contains double the mass of a typical white dwarf. And although not extremely unusual, it's still a bit strange and somewhat difficult to explain. One explanation is of course that maybe it was just created from a much larger, much brighter and much more energetic star, such as for example a B-type star, which would be about 5 to maybe 7 masses of the Sun. But another explanation is possibly more likely, and it's related to what the scientists just discovered somewhere else in the galaxy. They've discovered a pair of white dwarfs orbiting around one another with an orbit of only about 8.8 minutes, or essentially really close to each other. Now just to give you a comparison here, the closest planet to the Sun, Mercury, takes about 88 days to orbit once. Even when it comes to spinning, our Sun takes about 27 days to spin once around its own axis. And even the fastest spinning planet in the solar system, Jupiter, spins at just under 10 hours. Now, this is something that's way shorter. If we were to try to simulate their motion, it would look something like this. And in terms of the actual size of these objects, since both of them are roughly around the same size as our own planet Earth, both of them would easily fit inside Jupiter, and here's what Earth itself would look like if we were to place it in between these two objects. In other words, this is a pretty extreme system, but the thing is, this is not the most extreme. As a matter of fact, it was only actually a year ago or so when we originally found this system right here, where the orbit is even faster at roughly around 6.9 minutes. Suggesting of course that these systems are actually not rare at all. As a matter of fact, because we've discovered yet another system where white dwarfs orbit so close to one another, it presents a very reasonable explanation to how the beautiful Sirius B may have been created. There is a chance that this was a result of a combination of two smaller white dwarfs billions of years ago. Because what we believe is going to happen here is that these two white dwarfs are eventually going to combine with one another and turn into one larger, more massive object. Normally, for white dwarfs to go supernova, they actually have to be way more massive, specifically about 1.4 masses of the Sun, and in this case, the total mass of these two white dwarfs is roughly around 0.7 masses of the Sun, so they would need a lot more mass to go supernova. Although in this particular case, I'm actually kind of curious what's going to happen to planet Earth if I were to let the simulation run. And well, looks like it's probably going to fall apart and create a supernova. In this case, this was actually just a simulation. In reality, this is unlikely to happen, and what's more likely to happen is a very powerful collision between these two white dwarfs in approximately 400,000 years from now, resulting in the creation of a more massive but smaller in size white dwarf you see on the right, with the resulting white dwarf being a lot more massive but also being more hot. Currently, these two white dwarfs sort of look like this. The one that's slightly more massive is about 16,000 degrees Kelvin, the one that's slightly less massive is only about 6,000 degrees, so in some sense it's actually very similar to our Sun in its coloration. But once they combine, their temperature is probably going to be closer to about 20 to 25,000 degrees Kelvin, and they're also going to stay that hot for much longer periods of time. In other words, this white dwarf is going to be a very hot object for a very long time. But this is in far future, 400,000 years from now. because that's essentially how long it's going to take for these two objects to get closer and closer to one another. And at the same time, because these two objects are about 7,000 light years away from us, it's going to be somewhat difficult for us to actually see what happens to them at the end, even if we're still around in about 400,000 years from now. However, these findings are actually absolutely crucial for an upcoming observatory that's going to be in space. As a matter of fact, the scientists behind this paper believe that both this white dwarf binary and the previous record holder with the difficult name right here, where by the way ZTF stands for Zwicky Transient Facility, which is one of the Caltech major observatories, will actually be one of the best sources for the ESA's and NASA's LISA observatory. Or technically a space antenna, because LISA stands for Laser Interferometer Space Antenna. In a nutshell, LISA is going to be this. It's going to be a very large gravitational wave observatory orbiting around our planet and detecting all sorts of low frequency gravitational waves. So it's sort of like the LIGO observatory that can detect black hole collisions and neutron star collisions, but because of the size of LIGO, it can only detect high frequency gravitational waves. LISA, on the other hand, because of a dramatically larger size, as you can see it's thousands of kilometers, is going to be able to detect a lot of other collisions as well. Collisions between very large, very massive black holes, collisions between large gravitational bodies, but most importantly, collisions between objects like, for example, supermassive black holes that we haven't really been able to observe just yet. And in this case, because these white dwarfs orbit around one another every 8 minutes or so, the scientists in this paper, and of course other papers, believe that these white dwarfs are going to be the strongest sources of gravitational waves detected by LISA. It will only take a few months to discover these gravitational waves, but chances are we're going to be hearing this coming from everywhere. Because these objects are very dense and because they're quite massive, and most importantly because they're about 7,000 light years away from us, they are producing very powerful gravitational waves already. And these waves should be easily detectable by LISA and any other future observatory that's going to be similar to LISA in its concept. In other words, we're going to be probably hearing these waves coming from every single direction, and it will probably help us discover a lot of other hidden objects we didn't really know existed. But it will probably take some time before LISA becomes operational, and as a matter of fact, the current plan for the start of its operation is 2034. That's basically like 14 years from when I'm making this video. I'm gonna be much older by then, and so are you. Let's hope that someone else comes up with an idea a lot sooner than that. I can't wait 14 years to find out what's happening to these white dwarfs. Hey China, if you're listening, get on this. Maybe you can come up with a much better, much faster LISA. Anyway, on that note, that's kind of all we've discovered about this unusual binary. It's definitely interesting to discover objects that are so extreme that initially they don't actually make sense, until we start finding other similar objects somewhere in the vicinity. And because this is a second such binary with the orbit of under 10 minutes, we know that these have to be a lot more frequent than we initially thought. And also because these objects exist, it definitely gives a much easier explanation to the existence of Sirius B and other massive white dwarfs. It's a lot more likely that these massive white dwarfs were actually created through collisions like this, and not really through being created by larger stars, which are normally not as good at producing white dwarfs of a very specific mass. In other words, the existence of this white dwarf binary answers a lot of mysteries and a lot of questions once again. But on that note, once we learn something else about white dwarfs, or once we learn about some other interesting gravitational wave study, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support this channel on Patreon or by buying the Wonderful Person t-shirt you can find in the description. I'll see you tomorrow, space out, and as always, bye bye.